September 7th, 2025, total lunar eclipse, complete darkness. An object from another star system switched colours. Red to green, instantly. Cyanide production spiked 9 times. Industrial nickel flooded out, no iron. Harvard's watching, so is the Pentagon. In 20 days it disappears behind the sun, at the exact point where alien tech could break. What comes back in December might not be the same thing that went in. Because right now, as you're watching this, 3i Atlas is expelling 150 kilograms every second, but its trajectory hasn't changed at all. That's mathematically impossible unless it weighs 33 billion tons, 1,000 times more massive than any interstellar object we've ever seen. And here's what nobody's talking about. It sent a radio signal from the exact same cosmic neighborhood 48 years ago. The WOW signal, 0.6% probability that's random. Then it showed up perfectly aligned with our planetary plane, 0.2% probability. Time to pass Mars, Venus and Jupiter, 0.005% probability. You don't hit the lottery 3 times by accident. October 29th it goes dark, hidden from every telescope on Earth for 51 days. And when NASA's government shutdown happened on October 1st, 2 days before the Mars flyby that would have given us the clearest images ever, the data got buried. The high-resolution camera has 30-kilometer resolution. It saw something. We just don't know what yet. Harvard astrophysicist Avi Loeb gives it 30 to 40% chance of being alien technology. The scientific establishment calls him crazy, but the numbers don't lie. And the activation event during that eclipse? That wasn't gradual comet warming, that was a threshold, like something turned on. 3 observatories are watching the skies right now for UAP activity, because there's a theory that 3i Atlas isn't the threat, it's the distraction. While everyone watches the mothership, what's being deployed elsewhere? December 19th, it comes
on the left,
back,
a typical comet
closest
with a
approach to
diffuse,
Earth.
gentle coma. On the right,
We're about to find out if physics still works the way we think it does,
green coma.
or if something else has been running the experiment this whole time. If you're as fascinated by this mystery as I am, hit that like button and subscribe, and tell me in the comments where you're listening from, what time it is there, and if you think 3i Atlas could become dangerous for us. And if you want to help our community grow, share this on X, Facebook, Reddit, or your messenger. Thank you for always having our back. Also, check out our merch linked below the video. We've got some fun mugs and t-shirts you'll definitely love. This is a 2-part video. First, we dive into 3i Atlas, breaking down what Avi Loeb is actually trying to tell us. Then in part 2, we cover all the latest developments in science. Feel free to use the timestamps to jump to whichever section interests you most. Chapter 1. The activation event. The photographs came in during the early hours of September 8th. Michael Yeager and Gerald Raymond, 2 astrophotographers working from the dark skies of Namibia, had been tracking 3i Atlas for weeks. They'd chosen that particular night for a reason. A total lunar eclipse was unfolding overhead, which meant the moon's usual glow, that constant wash of reflected sunlight that drowns out faint objects, would be extinguished. For a brief window, the sky would be darker than it had been in months. They pointed their instruments toward Sagittarius, toward the region where 3i Atlas should be. What they captured wasn't what they expected. The object had changed colour. Every previous observation, every spectroscopic study conducted since the comet's discovery on July 1st had shown the same thing. 3i Atlas glowed with a reddish hue, the kind of colour you'd expect from an object covered in ancient radiation-weathered dust. Space has a way of turning things red over time. Cosmic rays bombard surfaces for millions of years, breaking down complex molecules into simpler, darker, redder compounds. It's the rust of the universe. But the images from September 7th showed something else entirely. A bright, almost luminous green. Not a gradual shift. Not a slow transition as the object warmed. The colour change appeared to be instant, threshold-like, as if someone had flipped a switch the moment darkness fell. Think about that for a moment. Comets don't work that way. When a comet approaches the sun, its surface heats gradually. Ice sublimates, gas escapes, dust particles lift off. The process is continuous, predictable. You can model it with fairly simple physics. Temperature rises, volatiles escape, brightness increases. It's a curve, not a step function. 3i Atlas didn't follow the curve. The timing raises questions that are hard to ignore. Why did the transformation happen during total darkness? If this was simple solar heating, the colour change should have been gradual, ongoing, tied to the object's decreasing distance from the sun. Instead, it appeared to correlate with the eclipse itself, with the removal of lunar light from the sky, as if the object had been waiting for observers to have their best possible view. Or as if it had been waiting for something else. The green colour itself tells a story. When astronomers see green in comets, they usually know what they're looking at. Dicarbon, a molecule made of two carbon atoms bonded together, emits light at a specific wavelength that appears green to our eyes, is a signature of organic chemistry, of carbon-rich ices being broken apart by sunlight. Comets like C-2022e3, the green comet that passed through our solar system in 2023, glow green because of dicarbon in their comas. But spectroscopic observations of 3i Atlas haven't detected dicarbon, at least not yet. The instruments pointed at this object should see that telltale emission line. If dicarbon were responsible for the colour, they don't. So what's making it green? Avi Loeb, the Harvard astrophysicist who's become both famous and controversial for his willingness to consider unconventional explanations, suggested an alternative: cyanide. On August 25, 2025, the Very Large Telescope in Chile's Atacama Desert detected something unusual in the coma surrounding 3i Atlas. Cyanide, specifically the CN molecule, was being produced at about 20 grams per second. That's not particularly strange on its own. Comets can produce cyanide. It's part of the complex chemistry that happens when organic rich ices meet solar radiation. What's strange is what happened next. As 3i Atlas moved closer to the sun, cyanide production didn't just increase, it exploded. The production rate climbed with the inverse of heliocentric distance raised to the power of 9, give or take 1. For those less familiar with mathematical relationships, that's an extraordinarily steep increase. Most cometary outgassing follows gentler power laws, typically between 2 and 4. 9 is off the charts. It's the kind of exponential spike you'd expect from a chemical reaction hitting a critical threshold, not from the gradual warming of ice. And cyanide, unlike dicarbon, can produce a greenish glow under the right conditions. If the concentration is high enough, if the excitation mechanism is right, you get green light. The wavelength isn't quite the same as dicarbon's signature, but to a camera capturing broad spectrum light, it would look similar. But here's where the story gets stranger. Cyanide wasn't the only thing spiking. Nickel. The Very Large Telescope's data showed nickel emissions increasing at the same dramatic rate, about 5 grams per second, climbing as the object approached the sun. Nickel in a comet's coma isn't unheard of. Many comets carry trace metals. When solar radiation heats the surface, these metals can be released as vapor, glowing in characteristic wavelengths as they absorb and re-emit light. The problem is what's missing. Nickel and iron are siblings in the cosmic abundance table. They form together in stellar cores, get ejected together in supernovae, condense together in planetary systems.
In other news tonight,
wherever you find nickel in natural space objects, you find iron. The ratio varies, but both are always present. It's one of those reliable patterns in astrophysics, like finding hydrogen wherever you find stars. 3i Atlas is expelling nickel without any detectable iron. The research team in Chile noted this in their paper, published in late August. They measured nickel emissions clearly. They looked for iron using the same instruments, the same methods. Nothing. The ratio was so skewed it didn't make sense within the framework of natural cometary composition. Loeb pointed out something that made the scientific community uncomfortable. There's one place where you regularly see nickel without iron: industrial production, specifically the carbonyl nickel channel, a process used in metallurgy to produce high-purity nickel. You heat nickel ore in the presence of carbon monoxide, form nickel tetracarbonyl, a volatile compound, then decompose it to get pure nickel metal. It's how we make nickel for alloys, batteries, specialized equipment. It's not how comets make nickel. The suggestion was clear, even if Loeb phrased it as a question. Is this anomaly further evidence for a possible technological origin of 3I Atlas? Could we be looking at industrial chemistry happening in space? Most astronomers rejected this immediately. The peer review process, the careful weighing of evidence, all pointed toward natural explanations. Perhaps the iron is there, but bound up in dust grains that don't emit light the same way. Perhaps the surface composition is unusual, enriched in nickel-bearing minerals through some quirk of formation. Perhaps the measurement is off, or the interpretation is wrong. Perhaps. But the timing of the green activation, the threshold-like behavior, the industrial chemistry signature, they cluster together in a way that's hard to dismiss entirely. Each piece alone could be explained. Together, they form a pattern. And there's one more detail that makes the activation event particularly intriguing: the brightness. Data released by the Atlas telescope team, using observations dating back to March 28, 2025, showed something unexpected about how 3I Atlas has been behaving. When the object was farther than 3.3 astronomical units from the Sun, farther than the distance between the Sun and the asteroid belt, its brightness increased in a specific way. The cross-section of scattered light, the amount of sunlight the object was reflecting, grew with the inverse of heliocentric distance to the power of 3.9. Then something changed when it got closer. The growth rate shifted. The relationship broke. Instead of continuing to brighten at the same rate, the object's behavior altered, as if a different process had taken over. The researchers suggested a physical mechanism. When 3I Atlas was far from the Sun, it was mostly scattering light off its reddish, dusty surface. As it moved closer, it began to release small, bright, icy particles, which increased the reflectivity of the surrounding coma. The transition from one regime to the other would naturally cause a change in how brightness scales with distance. That's a reasonable explanation. It fits known physics. But it also means that 3I Atlas underwent a transition, a shift in its physical state, at a specific distance from the Sun. Not gradually, not smoothly. It switched modes. The activation event during the eclipse might have been part of that transition, or it might have been something else entirely. We're left with photographs showing a dramatic colour change, chemical signatures that don't fit standard cometry models, and a brightness curve that suggests the object is responding to solar heating in ways we haven't seen before. September 7th was the night we stopped being able to explain 3I Atlas, using simple analogies to other comets. Something about this object is different. Whether that difference is natural or artificial, whether it's a quirk of unusual chemistry or evidence of technology, remains an open question. But the activation happened. The photographs exist. The spectroscopic data is real. And in the community of astronomers watching this object, a quiet unease is spreading. Because if 3I Atlas is just a comet, it's a comet that breaks the rules. And if it's not a comet, if there's even a small chance it's something else, then we need to start asking very different questions about what happens when it disappears behind the Sun in October. Questions like, will it come back the same? Chapter 2. The Decoy Hypothesis. There's a theory circulating among a small group of researchers that nobody wants to say out loud in official channels. It came from Omar El-Dadi, one of Avi Loeb's collaborators, And it's the kind of idea that sounds like science fiction until you start looking at the timing. The theory is simple. 3i Atlas isn't the threat, it's the distraction. Think about how you design a reconnaissance mission to a planetary system you'd never visited before. You wouldn't announce yourself. You wouldn't make a direct approach to the inhabited world. You'd want to observe without being observed, to gather data while remaining hidden. But there's a problem. Any civilization advanced enough to detect objects in space would eventually spot your probe. Telescopes improve, survey systems get better. Eventually you'd be found. So what do? You send something obvious, something big and bright and impossible to miss. Something that will consume every telescope, every observatory, every planetary defense system's attention. While they're all watching the obvious object, while they're debating whether it's natural or artificial, while they're writing papers and holding press conferences, your actual mission proceeds elsewhere, unnoticed, untracked. The decoy draws the eye. The real operation happens in the shadows. LD proposed this in a conversation with Loeb, framed as a thought experiment. But thought experiments have a way of becoming hypotheses when the data starts fitting too well. And the data around 3i Atlas fits uncomfortably well. Consider the object's behavior. It's massive, far larger than it should be. It's bright, easily visible to ground-based telescopes. It's moving on a trajectory that brings it close to multiple planets, ensuring maximum observation time. It exhibits anomalies, strange chemical signatures, unusual brightness patterns, all of which generate discussion and analysis and focused attention. It's almost perfectly designed to be noticed. But if you're trying to distract an entire civilization's astronomical infrastructure, you need more than just an interesting object. You need timing. You need the object to arrive when it will cause maximum focus, maximum resource allocation, maximum debate. 3i Atlas was discovered on July 1st, 2025. Within 24 hours, it was confirmed as interstellar. By July 3rd, major observatories worldwide were redirecting their instruments. The Hubble Space Telescope imaged it on July 21st. The James Webb Space Telescope observed it on August 6th. Spherex captured data from August 8th through 12th. The Very Large Telescope in Chile performed spectroscopy on August 25th. Every major astronomical facility, every space telescope, every planetary defense system capable of tracking fast-moving objects, they're all watching 3i Atlas. Hundreds of millions of dollars in equipment, thousands of hours of observation time, the focused attention of the global astronomical community, all pointed at one object. So the question becomes, what are we not looking at? Loeb took Eldadi's suggestion seriously enough to implement an actual monitoring program. The Galileo project, which he founded and leads, operates 3 observatories, one in Massachusetts, one in Pennsylvania, one in Nevada. Unlike traditional astronomical observatories that focus on distant objects, these facilities monitor the entire sky continuously. They're designed to detect fast-moving objects in Earth's atmosphere and near-Earth space, unidentified anomalous phenomena in the careful language of government reports, UFOs in the language everyone understands. The Galileo Project observatories use arrays of sensors, infrared cameras, optical cameras, radio detectors, audio sensors, magnetometers. They record everything, building a continuous movie of the sky. When something anomalous appears, when something moves in ways that don't fit known aircraft or satellites or meteors, the system flags it. The data gets analyzed. Patterns emerge. Loeb tasked his team with a specific mission: monitor UAP activity during 3i Atlas's perihelion passage. Look for correlations. See if anything else shows up in Earth's atmosphere or near-Earth space, while the astronomical community is focused on the interstellar visitor. The monitoring window is specific: October 31st, 2025, when 3i Atlas reaches its closest point to the Sun. That's when the object will be most active, most energetic, most likely to do whatever it's going to do. And that's when, if the decoy hypothesis is correct, whatever else is happening would proceed unobserved. The reasoning behind this gets into some uncomfortable territory. If an advanced civilization wanted to deploy probes into our solar system, how would they do it? You wouldn't launch them from your home system and hope they arrive intact billions of years later. Interstellar space is harsh. Radiation, micrometeorites, the slow decay of any mechanical system, even the most robust probe would degrade over that timescale. Instead, you'd send a mothership, something large enough to carry multiple smaller probes, equipped with the power and propulsion to make the journey. When you reach the target system, you don't just fly through once, you slow down. You enter a bound orbit around the host star. Then you deploy your probes, sending them to the places you want to study. Earth, Mars, Venus, the asteroid belt, Jupiter's moons, anywhere that might harbour life or resources or interesting phenomena. A mothership entering our solar system at 3i Atlas's speed, about 60 kilometers per second relative to the Sun, would need to brake. Hard. The most efficient place to do that is at perihelion, the closest approach to the Sun, using what's called an Oberth maneuver. You fire your engines when you're moving fastest, when you're deep in the Sun's gravity well. The physics of orbital mechanics means you get more delta V, more change in velocity for the same amount of fuel. It's the optimal strategy for an interstellar spacecraft trying to enter a bound orbit. 3i Atlas reaches perihelion on October 29th, behind the Sun, hidden from every telescope on Earth. If it were to perform a braking maneuver, we wouldn't see it happen. And if it were to release smaller probes during that hidden passage, sending them on trajectories toward the inner planets, we wouldn't see that either. Not immediately. The probes would be small, dark, moving on carefully calculated paths that minimize detection risk. They'd arrive at their destinations weeks or months later, long after 3i Atlas had moved on. By the time we realized something else was in the solar system, it would be too late to do anything about it. This is where the decoy hypothesis moves from uncomfortable speculation to actual concern, because there's a number that makes this scenario more plausible than it should be. 80 years. That's how long it would take an object moving at 3i Atlas's speed to travel from a base located at 1,000 astronomical units, 1,000 times the Earth-Sun distance, to reach the inner solar system. 1,000 AU is far, but it's not impossibly far. It's within the outer reaches of the Oort cloud, the vast sphere of icy bodies surrounding our solar system. An advanced civilization could establish a base there, hidden among billions of comets and frozen planetesimals, and we'd never know it existed. Our best telescopes can detect large objects out to about 10 times the Earth-Sun separation, maybe 20 if we're lucky and the object is bright. Beyond that, space becomes effectively dark to us. We can't see what's lurking in the outer solar system. We assume it's just comets and ice and empty space, but that's an assumption based on lack of data, not on comprehensive surveys. If there's a base out there, a station or outpost or waypoint placed by a civilization that knows how to navigate interstellar space, they could watch us for centuries, monitor our development, wait until we reached a certain technological threshold, then send something in. 3i Atlas could have been launched 80 years ago, 1945, right around the time humans first split the atom, right around the time we developed the capability to destroy ourselves on a planetary scale. That's the kind of threshold that might trigger a response from watchers, if watchers exist. All this could all be paranoid speculation, pattern matching on coincidences, seeing design where there's only chaos. But the Galileo project's instruments are recording regardless. The sky monitoring continues. If there's enhanced UAP activity during late October, if objects start appearing in Earth's atmosphere that don't fit conventional explanations, the data will show it. The sensors don't care about hypotheses or biases, they just record what's there. And that's what makes the decoy hypothesis testable, at least partially, If 3I Atlas is just a comet, UAP activity should remain at baseline levels. Random events, misidentifications, the usual noise in the data. But if something else is happening, if the distraction theory has any validity, the statistics would shift. More anomalies, tighter clustering in time, patterns that correlate with 3I Atlas's perihelion passage. We won't have to wait long to find out. The monitoring is happening now. The data accumulates every night. By the time 3I Atlas emerges from behind the sun in December, we'll know whether anything changed in our skies while we were watching the bright object everyone could see. The uncomfortable truth is that we're not equipped to detect a sophisticated deception. If an advanced intelligence wanted to observe us covertly while we're distracted by an obvious target, we don't have the sensor coverage or the analytical capability to catch it. We're barely managing to track near-Earth asteroids that could pose impact threats. Detecting stealth probes operating in Earth orbit would require infrastructure we haven't built yet. Which raises a question that keeps some researchers awake at night. If the decoy hypothesis is correct, if there's a mothership behind the sun preparing to deploy reconnaissance probes throughout the inner solar system, what exactly are we supposed to do about it? The answer right now is nothing. We watch, we record, we hope that whatever comes next is either benign or non-existent, because we're not ready for anything else. Chapter 3. The Shutdown That Wasn't Random. October 1st, 2025. The United States government shut down. Over 15,000 NASA employees were furloughed. Offices closed. Data pipelines froze. Communication channels went dark. 2 days later, 3I Atlas made its closest approach to Mars. The timing deserves attention. NASA's Mars Reconnaissance Orbiter carries a camera called HIRIS, the High-Resolution Imaging Science Experiment. It's designed to photograph the Martian surface in extraordinary detail, capturing features as small as 30 centimeters across from orbit. But cameras don't care what they're pointed at. If you turn HIRIS toward deep space, toward a fast-moving object passing near Mars, the resolution translates differently, 30 kilometers per pixel. That's enough to potentially resolve the nucleus of 3I Atlas, to see whether it's a single solid body or something more complex, to detect structural features if they exist. HIRIS took images on October 2nd and 3rd. The camera operators knew the schedule. They'd planned the observations weeks in advance. The data was collected, stored, ready for processing and release. Then the government shut down, and the data stayed locked inside NASA's servers. Stephen Miller, the White House Deputy Chief of Staff for Policy, gave an interview on October 3rd. During the segment, which aired on national television, he was asked a direct question. Has the president been briefed about 3I Atlas? The question wasn't random. It came from a journalist who'd been following the story, who knew about Loeb's papers, who understood that an interstellar object exhibiting anomalous properties might warrant executive attention. The kind of thing that would normally trigger classified briefings, contingency planning, coordination between agencies. Miller's answer was carefully non-committal. He acknowledged awareness of the object but declined to confirm or deny presidential briefings, standard protocol when you don't want to discuss classified information in public. But the fact that the question was asked at all, that it made it through editorial review and onto national television, suggests that someone in the chain of communication thought it was worth pursuing. The timing loops back to haunt you when you look at the sequence. The shutdown began October 1st. The Mars flyby happened October 3rd, and on October 4th, just 24 hours after the closest approach, certain mainstream media outlets received preliminary briefings from NASA sources characterizing 3I Atlas as an ordinary comet. No technical reports, no images, no spectroscopic data, just verbal assurances that everything was normal, nothing to see, move along. NASA's official position is that processing high-resolution data takes time. The images need calibration. The team needs to analyze what they're seeing before releasing anything to the public. This is standard procedure. Premature release of uncalibrated data can lead to misinterpretation, false conclusions, unnecessary panic. All of that is true. It's also true that rushing out verbal characterizations before completing the analysis seems inconsistent with the careful approach NASA normally takes. If the data needs days or weeks of processing before it can be properly interpreted, why brief media outlets 24 hours after collection? Why not wait until the full analysis is complete? Loeb's response to questions about the shutdown was pointed. When people asked him whether the delay in releasing data might indicate a conspiracy to hide evidence of extraterrestrial intelligence, his answer became a quotable soundbite. The delay is not the signature of extraterrestrial intelligence, it's more a signature of terrestrial stupidity. It's a good line. It frames the situation as bureaucratic incompetence rather than malicious intent, and bureaucratic incompetence is certainly the simpler explanation, the one that requires fewer assumptions, the one that aligns with Occam's razor. But timing is a stubborn thing. It doesn't care about simplicity or elegance. It just sits there in the data, refusing to be ignored. The European Space Agency faced no shutdown. Their Mars orbiters, the ExoMars Trace Gas Orbiter and Mars Express, both captured images of 3i Atlas on October 3rd. ESA released those images on October 7th. 4 days of processing, which is reasonable for an unexpected target using instruments designed for surface imaging. The images show a fuzzy white dot against the black of space. Not much detail. The cameras weren't optimized for observing distant objects. But they released what they had. Raw, preliminary, uncalibrated. Here's what we saw. Make of it what you will. NASA's approach was different. Silence during the shutdown. Verbal briefings to select outlets characterizing the object without showing the data. Then continued silence about the high-res observations, which should have provided significantly better resolution than anything ESA captured. The Chinese Space Agency operates Tianwen-1, another Mars orbiter with imaging capability. The United Arab Emirates operates the Hope orbiter. Both were in position to observe 3i Atlas. Neither has released data publicly. Whether they captured useful images, whether they're analyzing what they found, whether they're sharing that analysis with other agencies, all of that remains unknown. Radio silence is sometimes a choice. Sometimes it's protocol, and sometimes it's the sound of people trying to figure out what they're looking at before they tell anyone else. There's a pattern in how governments handle information that doesn't fit existing frameworks. First comes confusion, then comes classification, then comes the careful drip of sanitized details designed to manage public response. It's not necessarily malicious. It's the institutional immune system protecting itself from chaos. If 3i Atlas is just a comet, if the data shows nothing unexpected, then the delay is meaningless. Processing takes time. Shutdowns cause disruption. Everything will be released eventually, and it will all make sense. But if the data shows something that can't be easily explained, if high-res captured images that raise more questions than they answer, then the silence becomes strategic. You don't release confusing information during a government shutdown when you can't provide proper context, can't coordinate messaging across agencies, can't prepare the scientific community for what they're about to see. You wait, you analyze, you build consensus, and then you release it in a controlled way that minimizes disruption. Or you never release it at all, and you let people assume the data was unremarkable. Amateur astronomers tried to fill the gap. One YouTuber operating under the name Dobsonian Power posted images captured on October 3rd claiming to show unusual structural features in 3i Atlas. The images spread rapidly across social media. Thousands of shares, hundreds of comments. Is this evidence of artificial structure? Is this the proof we've been waiting for? Analysis by other astronomers poured cold water on the excitement. The images were captured using solar observation equipment, not deep space imaging tools. Heavy digital enhancement amplified noise into apparent structure, atmospheric turbulence, optical aberrations, processing artifacts, all combining to create patterns that looked meaningful but weren't. It's a reminder that we're desperate for clarity. We want answers. We want high-resolution images that show us definitively what this object is, and in the absence of official data, we'll accept amateur observations, wishful thinking, anything that fills the void. The void exists because the people with the best instruments, the ones who actually have the data we need, aren't sharing it. Whether that's due to incompetence or intention, the effect is the same: uncertainty, speculation, growing unease. What did HiRISE see? The camera has the resolution to potentially answer fundamental questions about 3I Atlas. Is it a single solid nucleus or a loose aggregate? Does it show surface features consistent with natural formation or something else? Is there any geometric structure? Any sign of components that don't fit the rubble pile model? Those images exist. Somewhere in NASA's data systems, the raw files are stored. Photons from 3I Atlas hit HiRISE's detector. Information was captured. The answers to at least some of our questions are sitting in a database waiting to be processed and released. Days pass, then weeks. The government shutdown ends, operations resume, and still no HiRISE images of 3I Atlas appear in the public archive. You can check. The HiRISE team maintains a database of all observations. You can search by date, by target, by coordinate. The October 2nd and 3rd observations should be there. They're not. Or they're not tagged in a way that makes them easily findable. Or they're undergoing extended processing for reasons unexplained. Radio silence from the highest resolution camera that had a clear view of the most interesting interstellar object to visit our solar system in years. Maybe it's nothing. Maybe the bureaucracy is just slow. Maybe we'll see the images eventually, and they'll show exactly what we expect to see. A slightly irregular comet nucleus surrounded by a dusty coma. Nothing unusual. Case closed. Or maybe the silence itself is the signal. Not evidence of conspiracy, but evidence of confusion. People trying to understand what they're looking at before they show it to the world. Scientists arguing over interpretation. Administrators weighing the risks of releasing data that might be misunderstood. The shutdown gave everyone an excuse for the delay. Blame the politicians, blame the budget crisis. Don't blame the astronomers who are just trying to do their jobs. But the shutdown didn't stop ESA from releasing their images. It didn't stop amateur astronomers from posting their observations. It only stopped NASA, the agency with the best data, from sharing what they found. And that absence speaks louder than any official statement could. Chapter 4. The Scientific Civil War. Jason Wright sits in his office at Penn State University, a tenured astronomer with credentials that can't be easily dismissed. He runs a blog called Astro Wright, where he discusses his research, comments on papers, engages with the broader astronomical community. In late July 2025, he wrote a post titled Avi and 3I Atlas. The post was not kind. Wright went through Loeb's analysis point by point, methodically dismantling arguments about image smearing, coma detection, spectroscopic data. He called out what he saw as fundamental misunderstandings of how astronomical observations work. The tone was exasperated. The kind of frustration that comes from watching someone with a large platform make claims that don't hold up to scrutiny. One particular section stood out. Wright quoted from Loeb's preprint paper, "The line about how the fuzz observed around 3I Atlas is inconclusive given the motion of the object and the inevitable smearing of its image over the exposure time." Then Wright explained why that's wrong. Comet astronomers don't track stars when observing comets. They track the comet. The telescope follows the object across the sky, keeping it centered in the frame. Stars smear, the comet stays sharp. That's basic technique. the kind of thing any planetary scientist learns in graduate school. Loeb dismissed observations of 3I Atlas's coma by claiming they were artifacts of tracking error. But the observers weren't making tracking errors. They were doing their jobs correctly. The coma was real. Wright's conclusion was blunt. This is sloppy work beneath the level of an undergraduate. Then he assigned it a grade. The blog post included an actual grading rubric, filled out as if Loeb had submitted a homework assignment. The final mark was failing. That's not how scientific disagreements usually play out. Researchers write response papers. They present counter-evidence at conferences. They engage through formal channels, maintaining professional courtesy, even when they think a colleague is catastrophically wrong. You don't publicly grade another scientist's work like they're a student who didn't study for the exam. Unless you've reached a point where professional courtesy seems less important than preventing misinformation from spreading. Unless you think the normal channels aren't working, that the careful process of peer review and academic discourse is being bypassed by blog posts and media interviews, and someone needs to say plainly that the Emperor has no clothes. Wright wasn't alone. Other astronomers, people who work with comets and asteroids and interstellar objects, expressed similar frustration. Most did it privately. Some did it in seminars and departmental meetings. A few were willing to go on record with journalists, though usually with careful qualifications. It's unusual. It doesn't fit standard models. But it's probably natural. We need more data. The word probably does heavy lifting in those sentences. What almost none of them said publicly, what you only hear in private conversations over coffee or late at night at conferences, is that engaging with Loeb's theories gives them oxygen. The more you argue, the more attention the ideas receive. The controversy becomes the story. Media outlets love conflict. Harvard professor claims alien mothership versus establishment scientists say it's just a comet. That's a headline that drives clicks. So most astronomers chose silence. Not because they agreed, not because they couldn't refute the claims, but because refutation amplifies the original message. It's a trap. Engage and you spread the idea to wider audiences. Ignore it and the idea spreads anyway, but at least you're not helping. This creates a vacuum. The public hears one articulate, credentialed voice saying extraordinary things. They hear a few rebuttals, often technical and hard to follow, and they hear a lot of silence from people who should have opinions but won't share them. Into that vacuum flows speculation, conspiracy thinking, the assumption that silence equals suppression. Steve Desch, an astrophysicist at Arizona State University, broke the silence in a different way. He didn't write a blog post. He graded the paper on social media, showing his calculations for what happened to be wrong. Sorry it took me so long to grade your August 20th assignment, Avi Loeb. Are you sure you're ready for a class on comets? You might need to learn about things like bow shocks and chemistry. The mockery was pointed. Desch has spent his career studying how planetary systems form, how objects in space behave, how to interpret the data we collect. When someone with Loeb's platform makes claims that contradict basic physics, claims that require ignoring well-established processes, the frustration becomes personal. Because it's not just about being wrong. Everyone is wrong sometimes. Science progresses through mistakes corrected, hypotheses tested and discarded. The problem is what happens when someone influential keeps making the same types of errors, refuses to engage with the technical rebuttals, and continues to promote ideas that the broader community considers deeply flawed. Tom Statler works at NASA as the lead scientist for solar system small bodies. His job involves coordinating observations, understanding what telescopes are seeing, translating complex data into coherent narratives. When journalists asked him about 3I Atlas, his response was measured but clear. It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know. Statler acknowledged that 3I Atlas has unusual properties. The chemistry is weird. The trajectory is interesting. It's worth studying carefully, but unusual doesn't mean artificial. Nature is creative. The universe produces objects that surprise us, that don't fit neatly into existing categories. That's how we learn. That's how science advances. His argument was essentially, yes, it's strange, but strange things happen in nature all the time, and we have no compelling reason to invoke technology where natural processes can explain what we're seeing. The scientific community largely agrees with Statler. When you survey astronomers, when you ask what they think Three-Eye Atlas is, the overwhelming consensus is that it's a comet with some unusual characteristics, probably due to quirks in its formation or composition. Nothing that requires invoking alien intelligence. Nothing that can't be explained by physics we already understand. But consensus isn't the same as certainty, and there's a difference between explaining something in principle and explaining it in detail. Yes, in principle, a comet could have a forward-facing jet. In principle, it could show extreme nickel emissions without iron. In principle, it could have a carbon dioxide to water ratio 8 times higher than any comet we've seen. In principle, each anomaly has a natural explanation. The question is whether all those principles stretch too far when you stack them together. At what point does in principle possible become implausibly unlikely? Loeb's response to his critics has been consistent. He welcomes the data. He'll change his assessment when the evidence warrants it. He's proposed a scale, called it the Loeb scale, where 0 is definitely natural and 10 is definitely technological. He's placed Three-Eye Atlas at different points on that scale as new information arrives. Currently, he says 30 to 40% chance of non-natural origin. That number infuriates his critics. It's not based on rigorous Bayesian analysis. It's not derived from a formal probability model. It's a gut feeling dressed up as quantification, and gut feelings, no matter how experienced the gut, don't constitute scientific evidence. But Loeb argues that his critics are making the same mistake in reverse. They're assigning near-zero probability to the technological hypothesis without rigorous justification. They're assuming natural origins because that's the default, because that's what we've always found before, because invoking intelligence feels like giving up on science. He points to history. When pulsars were discovered, the signals were so regular that astronomers half-seriously called them LGM-1, LGM-2, little green men. The idea that these could be artificial was considered briefly, then discarded when natural explanations emerged. Neutron stars rotating at precise intervals, lighthouse beams sweeping across space. Nature could produce those signals, no intelligence required. But what if nature couldn't produce the signals? What if no known physical process could explain what was observed? At what point would the scientific community seriously entertain the possibility that we detected technology? And how much evidence would be required before that possibility became the leading hypothesis? Those questions don't have clear answers. Science doesn't have a protocol for this situation. We've never found artifacts from another civilization. We don't know what the evidence would look like. We don't know how to weigh anomalies against the vastness of prior probability. So we argue, Loeb on one side claiming we should keep an open mind, that dismissing possibilities without investigation is itself unscientific. The establishment on the other side claiming that extraordinary claims require extraordinary evidence, and the evidence so far is interesting but nowhere near extraordinary. The Civil War plays out in papers and blog posts and conference presentations. It plays out in funding decisions, in which proposals get approved, in who gets telescope time for follow-up observations. It plays out in media coverage, in public perception, in whether people trust scientists to tell them the truth about what's happening in their solar system. And through it all, Three-Eye Atlas continues its journey, indifferent to the debate, following its trajectory regardless of what humans think about it. The object doesn't care whether we call it a comet or a spacecraft. It will do what it's going to do. The data will ultimately settle the argument, not blog posts, not Twitter threads, not interviews on cable news, observations, measurements, the stubborn facts of what happens when 3I Atlas reaches perihelion, when it emerges from behind the Sun, when it continues outward past Jupiter and eventually leaves our solar system entirely. Until then, the scientific civil war continues, and the casualties are measured not in careers destroyed but in public trust eroded, in the growing sense that maybe scientists don't know as much as they claim. Maybe the experts are too quick to dismiss ideas that threaten their worldview. Maybe the establishment is more interested in maintaining consensus than discovering truth. That erosion matters, because if 3I Atlas does turn out to be something unexpected, if evidence emerges that can't be ignored or explained away, we're going to need public trust in scientific institutions to help process what that means, and right now, that trust is fracturing along the same lines as the debate itself. Chapter 5. The Mathematics of Impossibility. 4,000 observations, 227 observatories, 5 months of tracking. Avi Loeb and his team had compiled every available measurement of 3I Atlas's position as it moved across the sky. The data came from professional observatories, amateur astronomers, automated survey systems, anyone who'd pointed a telescope at the object and recorded its coordinates. They fed all of it into orbital calculation software, the kind that can determine trajectories to extraordinary precision when you have enough data points. What they found was an object following a path shaped purely by gravity. No deviations, no unexplained accelerations, just the elegant mathematics of an object moving through the Sun's gravitational field, exactly as Newton's laws predict. That should have settled the question. Natural origin. Case closed. Except for one problem, the object is losing mass. The Hubble Space Telescope image from July 21st showed it clearly. A plume of material extending from 3I Atlas toward the Sun, about 10 times longer than it was wide. Material being expelled from the sunward side, carried away by some combination of sublimation and pressure. When you lose mass in a preferred direction, physics demands that you accelerate in the opposite direction. It's conservation of momentum. Throw something forward, you move backward. Comets do this constantly. As ice sublimates and gas jets away, the comet experiences a tiny push, a non-gravitational acceleration that changes its orbit slightly. Astronomers can measure these accelerations. They're small, but they're real and detectable when you have enough observations. You see the object shift from a purely gravitational path. The math shows the deviation. 3I Atlas shows no deviation. 0 measurable non-gravitational acceleration despite clear evidence of mass loss. Loeb did the calculation. If the object is losing 150 kilograms per second, which is consistent with what Hubble observed, and if that mass is being expelled in a jet pointing toward the Sun, then conservation of momentum says the object should be accelerating away from the Sun. The acceleration should be detectable in the orbital data. It should show up as a small but measurable change in trajectory. It doesn't. The only way to reconcile these facts is if the object is much more massive than expected. If it weighs enough that 150 kilograms per second is negligible, like throwing pebbles off an aircraft carrier, the ship doesn't slow down because the mass ratio is absurd. How massive would 3I Atlas need to be for the mass loss to be undetectable? Loeb calculated it. 33 billion tons, minimum. At the density of solid rock, about 2.5 grams per cubic centimetre, that mass translates to a diameter of about 5 kilometres, the width of Manhattan Island. That's not a comet nucleus, that's a small asteroid. But asteroids don't produce jets. They don't expel material toward the Sun. They're solid rock, not ice. The whole reason we think 3I Atlas is a comet is because it's doing things only comets do. So we have an object that acts like a comet but needs to be as massive as an asteroid to explain why its trajectory isn't changing. The math doesn't care about our categories, it just demands internal consistency, and right now, the pieces don't fit together cleanly. the SphereX Space Observatory complicated things further. Between August 8th and 12th, it captured infrared observations of 3I Atlas. Based on the brightness at 1 micrometer wavelength, assuming a reasonable albedo, the team calculated a diameter of 46 kilometers. That's 10 times larger than the minimum mass estimate. If SphereX is right, 3I Atlas isn't just Manhattan-sized, it's bigger than many asteroids in the main belt. 46 kilometers means a mass around 1 trillion tons, 1 million times more massive than 2I Borisov, the previous interstellar comet. That creates a statistical nightmare. Interstellar space isn't empty, but it's not crowded either. Based on what we know about stellar systems, planet formation, and the rate at which objects get ejected into interstellar space, we can estimate how much material is out there per unit volume. Rocky objects, icy objects, various size distributions. The numbers tell us that discovering a 46-kilometer interstellar object within a decade of survey operations is spectacularly unlikely. We should have found hundreds or thousands of smaller objects first. 2I Borisov-sized comets should be common. Manhattan-sized objects should be rare. Objects 50 times larger should be essentially non-existent in the sample we'd collect in 10 years. Yet here it is, the third interstellar object ever confirmed, and it's a giant. Loeb pointed this out in his first paper on 3I Atlas, the reservoir argument. If you want to deliver one 46-kilometer rock into the inner solar system per decade, you need a certain density of such objects in interstellar space. When you calculate that density, it exceeds what stellar systems can reasonably produce by about 4 orders of magnitude, 10,000 times too much material. Either we've been extraordinarily lucky catching the rare giant on only our 3rd try, or something about our assumptions is wrong, or the object isn't a random sample from the interstellar population. Statistics can't prove anything is artificial, but they can tell you when something is surprising. When you flip a coin and get heads 3 times in a row, you don't immediately assume the coin is rigged. But if you flip it 100 times and get heads every single time, you start looking very carefully at that coin. 3I Atlas is the statistical equivalent of a suspicious coin. Every measurement adds another improbability. The trajectory aligned with the ecliptic plane rare. The timing to pass multiple planets extremely rare. The mass far exceeding expectations implausible. The chemistry showing industrial signatures unusual. The activation during the eclipse unexplained. Each one individually could be chance. Together, they form a pattern that makes statisticians uncomfortable. And there's one more number in the pile, the most unsettling one, the connection to the WOW signal. August 15th, 1977. The Big Ear radio telescope at Ohio State University detected a powerful narrowband signal at 1420.456 MHz. 72 seconds of transmission, 30 times stronger than background noise, right on the hydrogen line frequency that SETI researchers consider the universal hailing channel. Astronomer Jerry A. Mann wrote, "Wow," on the printout. The signal never repeated. The coordinates were recorded. Right ascension 19 hours 25 minutes. Declination negative 27 degrees. The direction was Sagittarius, toward the galactic center, a region crowded with stars. Loeb calculated where 3I Atlas was on August 15th, 1977. Not where it is now, but where it would have been 48 years ago, working backward along its trajectory. The object would have been roughly 600 astronomical units from Earth, still approaching, moving at its characteristic speed of 60 kilometers per second. The direction? Right ascension 19 hours 40 minutes, declination negative 19 degrees. The separation is 9 degrees. In a sky covering 41,000 square degrees, 2 random directions have about a 0.6% chance of being aligned within 9 degrees of each other. Could be coincidence. The galaxy is full of stars in that direction. The WOW signal could have come from any of them, or from none of them. if it was some terrestrial interference that somehow passed all the filters designed to exclude false positives. But if 3i Atlas transmitted that signal 48 years ago, if it was testing Earth's detection capability or announcing its presence or scanning for radioactivity, what kind of transmitter would it need? Loeb worked through the numbers. At 600 AU, producing a signal strong enough to register at the Big Ear telescope's sensitivity would require between 0.5 gigawatt and 2 gigawatts of power. That's the output of a large nuclear reactor. It's within the range of power generation we can imagine for an advanced spacecraft. Not impossible. Not requiring physics we don't understand. Just engineering at a scale beyond what humans have achieved in space. And if the signal was transmitted 48 years ago from an object that just now happens to be passing through our inner solar system, that implies timing, planning, a trajectory calculated to arrive decades after the initial signal, giving the target civilization time to develop detection capabilities, time to become aware they're being watched. Or it implies that we're very good at finding patterns in random noise, that 9 degrees is close enough to be interesting but not close enough to be convincing, that the whole thing is coincidence stacked on coincidence wrapped in wishful thinking. Mathematics can calculate probabilities. It can tell you how likely something is under various assumptions. What it can't do is tell you which assumptions are correct. The numbers show that 3i Atlas is unusual by multiple independent measures. Whether that unusualness means technology or just rare natural circumstances, mathematics alone can't answer. But the numbers keep piling up. 33 billion tons minimum mass, 46 kilometers possible diameter, 0.6% probability for signal alignment, 0.2% for ecliptic trajectory, 0.005% for planetary timing. Multiply small probabilities together and you get very small probabilities. At some point, very small becomes suspicious. At some point, the coincidences demand explanation. We're not at that point yet. The scientific community hasn't reached consensus that something genuinely anomalous is happening. But we're closer than most people realize. A few more unexplained data points, a few more measurements that don't fit the models, and the mathematics of impossibility starts looking less like coincidence and more like signal. The question is, what happens when we cross that threshold? When the numbers stop allowing comfortable explanations? When the improbabilities accumulate beyond what chance can reasonably produce? Do we trust the mathematics? Or do we trust our intuition that the universe doesn't work that way? That aliens don't visit solar systems? That extraordinary claims need extraordinary proof even when the ordinary explanations have stopped working? The data doesn't care about our comfort. It just keeps arriving, measurement after measurement, building a case that something about 3i Atlas doesn't fit the story we want to tell. Chapter 6. What Happens in the Dark. October 29th, 2025. 3i Atlas reaches perihelion, its closest approach to the Sun. 1.36 astronomical units, about 203 million kilometers, just inside the orbit of Mars. From Earth's perspective, the object disappears. Not because it stops existing, because the Sun gets in the way. When you're standing on Earth looking outward into space, the Sun occupies a region of sky you can't observe. Too bright. Point a telescope toward the Sun and you get blinded sensors, ruined instruments, no useful data. There's a zone of avoidance around our star, a blind spot that extends several degrees in every direction. 3i Atlas will be inside that blind spot from late October through late November. 51 days of darkness. 51 days when no telescope on Earth can see what's happening. The timing is almost poetic. The most critical moment in the object's passage, the point where it's most active, most energetic, most likely to do something unexpected, happens behind a wall of light we cannot penetrate. If you were designing a trajectory to minimize observation during a key maneuver, you'd aim for perihelion on the far side of the Sun from Earth. You'd arrange your orbit so that when you're closest to the star, when you're moving fastest, when you have maximum access to gravitational energy for an Oberth maneuver, your target planet can't see you. 3i Atlas achieves this accidentally, or intentionally. The distinction matters only if you believe intentions are involved. An Oberth maneuver is elegant physics. When you're deep in a gravity well moving at high speed, your kinetic energy is enormous. Fire your engines at that moment, add velocity when you're already moving fast, and you gain more change in orbital energy than you would anywhere else along your path. It's the most efficient place to brake if you want to slow down, or to accelerate if you want to speed up. For an interstellar object moving at 60 km per second, reaching perihelion offers a chance to fundamentally alter trajectory. Without an Oberth maneuver, 3i Atlas is bound for exit. Its hyperbolic orbit will carry it past the Sun and back out into interstellar space. But apply thrust at perihelion even a few kilometers per second of delta V, and you can change a flyby into capture. You can enter a bound orbit around the Sun. Or you can adjust your trajectory toward a specific target: Earth, Mars, Jupiter, wherever you want to go next. The amount of thrust required isn't absurd. A velocity change of 30 to 40 kilometers per second during October would be sufficient to intercept Earth between December the 26th, 2025 and January 9th, 2026. That's assuming you start the maneuver while hidden behind the Sun, adjust your path while no one is watching, then emerge on a new trajectory that casual observers might not immediately recognize as different. Loeb and his co-authors calculated this in their paper. The numbers are there in Figure 4 showing delta V requirements for intercepting various planets at various times. Earth requires more thrust than the closer planets because of orbital mechanics, but it's still within the range of what advanced propulsion could achieve. Chemical rockets could do it. We've built systems capable of 30 km per second delta V changes. They're large and expensive and require enormous fuel mass, but they exist. A civilization capable of interstellar travel would have better options: nuclear thermal propulsion, fusion drives, technologies we can imagine even if we can't build them yet. 30 kilometers per second becomes trivial if you're not constrained by rocket equation limitations. So the possibility exists: an object hidden behind the Sun at the optimal point for trajectory modification, with the thrust requirements to reach Earth within 2 months. The question is where the possibility translates to probability, whether we should take this scenario seriously or file it under science fiction. Financial markets apparently consider it worth thinking about. Loeb mentioned in one of his interviews that if 3i Atlas were to maneuver toward Earth, if it emerged from behind the Sun on a collision trajectory, the stock market would crash. Not because an impact is likely. 3i Atlas isn't large enough to cause extinction-level damage. But because a maneuvering interstellar object means technology, means intelligence, means the fundamental assumption that we're alone is wrong. That realization would cascade through every system humans have built. Economic models assume certain boundary conditions. Political frameworks operate within defined parameters. If those boundaries suddenly expand to include active alien civilizations monitoring our solar system, nothing stays stable. Uncertainty spikes. Risk calculations break. The models we use to predict the future stop working. So yes, the market would crash, not from physics, from psychology. But markets crashing assumes we'd know about the maneuver, assumes 3i Atlas emerges visibly altered, obviously on a new path, undeniably heading somewhere it shouldn't be going. What if the change is subtle? What if the object's new trajectory looks natural enough that only careful analysis reveals the deviation? What if it emerges from behind the Sun and continues outward, apparently unchanged, but with small course corrections that will manifest later? We wouldn't know until months afterward, until someone recomputes the orbit using post-perihelion data and notices the discrepancy. By then, the object could have deployed probes, released payloads, accomplished whatever it came to do. The hidden passage creates opportunity for deception. not because the sun is actively hiding anything, just because timing and geometry align to create a gap in our surveillance. A natural blind spot that any intelligence would exploit if given the chance. December brings visibility again. 3i Atlas should emerge from behind the sun in early December, becoming observable from Earth once more. The object will be outbound, moving away from the sun, continuing its journey toward the outer solar system. Telescopes will reacquire it, observations will resume, and within a few weeks we'll have enough data to calculate the new orbit. That calculation will answer questions. Did the trajectory change? Is the object still on its original hyperbolic path, or has something altered? Are there unexplained accelerations, course corrections, maneuvers? If the orbit is unchanged, if 3i Atlas continues exactly as predicted, then perihelion was uneventful. The object passed close to the sun, warmed up, expelled more gas and dust, but remained fundamentally inert. A comet doing comet things, nothing more. If the orbit changed even slightly, we have a problem. Natural comets don't perform O-berth maneuvers. They don't make trajectory adjustments at perihelion. Any deviation from the predicted path would be evidence of forces beyond gravity, beyond normal outgassing, beyond anything a passive ice ball should produce. The stakes of that December calculation are higher than most people realize. It's not just academic curiosity, it's a test. Either we confirm our understanding of what this object is, or we confront the possibility that our understanding is wrong. December 19th, 2025. 3i Atlas makes its closest approach to Earth. Still distant 269 million kilometers, but closer than it's been since discovery. Close enough for every major telescope to observe simultaneously. Close enough to gather enormous amounts of data in a short time window. The astronomical community is preparing. Observation proposals have been submitted. Telescope time has been allocated. Space-based observatories are scheduling pointing windows. If there was ever a moment to get definitive data about 3i Atlas, December 19th is it. But by then, the critical moment will have passed. Whatever happened at perihelion will have already happened. December observations will tell us the aftermath, not the event itself. We'll see the results, not the process. That's the frustration at the core of this whole situation. We're always observing after the fact, always reconstructing what happened from clues and traces. The universe doesn't perform for our benefit. Events occur whether we're watching or not, and the most interesting events have a way of happening when we're not looking. 3i Atlas didn't choose its trajectory to hide during perihelion. Orbital mechanics determined that. The object is following the path physics dictates, indifferent to our observational limitations. The fact that this path creates a blind spot at the most crucial moment is just geometry. But if you were an intelligence navigating interstellar space, if you were choosing when to make critical maneuvers, if you understood that the civilizations you're visiting would have blind spots in their surveillance, you'd time your actions accordingly. You'd perform the sensitive operations when the observers can't see. You'd wait for the geometry to favor concealment. And you'd count on your targets assuming it was all natural, all coincidence, all the product of physics and chance rather than design and intention. Maybe that's exactly what's happening right now. October 29th, the sun blazes between Earth and 3i Atlas. The object moves through perihelion, hidden, unreachable, doing whatever it's going to do in the privacy darkness provides. Or maybe it's just a comet, warmed by solar radiation, expelling gas and dust, following a path determined 4 billion years ago when it first formed in some distant star system. Maybe the blind spot is irrelevant because there's nothing to hide. We'll find out in December, when the geometry shifts, when 3i Atlas emerges back into observable space, when we can point our instruments at it once more and calculate what, if anything, changed during those 51 days of darkness. Until then, we wait, and we wonder what happens in the places we cannot see. Chapter 7. Conspiracy Theory Thunderdome. The Jeffrey Epstein distraction theory emerged within 72 hours of 3I Atlas's discovery. Social media posts claimed the announcement was time to bury news about unsealed court documents, that the government needed a big science story to dominate the headlines, while uncomfortable revelations about powerful people faded from public attention. Loeb's response was characteristically direct. 3I Atlas is a physical object in the sky at a large distance from Earth that cannot be faked because it was observed independently from different directions by the Hubble Space Telescope and ground-based telescopes. You can purchase a 0.5 meter telescope yourself and look at it. Its existence has nothing to do with terrestrial politics. The object exists. Anyone with decent equipment can verify this. The timing of its discovery correlates with when it became bright enough to detect, not with any news cycle. Suggesting otherwise requires believing that astronomers worldwide coordinated a hoax involving fabricated data from multiple independent facilities. But conspiracy thinking doesn't work that way. It doesn't require comprehensive coordination. It just requires doubt. Once you introduce the possibility that something is being hidden, that authorities aren't telling the whole truth, every subsequent piece of information gets filtered through that lens. Confirmation becomes evidence of cover-up. Denial becomes evidence of cover-up. The theory becomes unfalsifiable. Other variants appeared. Anti-Semitic attacks on Loeb specifically, suggesting his Jewish or Israeli background influenced his analysis, that he had ulterior motives for promoting alien theories, as if ethnic heritage determined scientific conclusions, as if nationality matters more than data. Loeb noted these attacks in his blog with a kind of weary resignation. This led me to realize that the simplest solution to Fermi's question, "Where is everybody?" is that the aliens do not consider us sufficiently intelligent to be worth their attention. Given these conspiracy theories, I do not blame them. It's a cutting observation. If we can't distinguish between physical objects observable by anyone with a telescope and elaborate government distractions, if we attribute scientific analyses to ethnic conspiracies rather than evidence, maybe we're not ready for contact with advanced intelligence. Maybe we're still too tribal, too quick to suspect hidden agendas, too unwilling to accept that sometimes a comet is complicated without being a hoax. But then, there are the theories that aren't so easy to dismiss, the ones that don't require believing in coordinated hoaxes or ethnic conspiracies, the ones that take the data seriously and extrapolate into strange places. The Oumuamua communication network theory started on Reddit, spread to Twitter, eventually made it into blog posts and YouTube videos. The idea is simple. 3I Atlas didn't arrive alone. It's communicating with Oumuamua, the first interstellar object which passed through our solar system in 2017 and is now heading back out into deep space. According to this theory, the WOW signal wasn't sent to Earth. It was sent from Oumuamua to 3I Atlas, a relay message. Oumuamua performed its reconnaissance, gathered data about the inner solar system, detected Earth's radio emissions, then sent a report back toward the direction from which 3I Atlas was approaching. The signal we detected was leakage, the equivalent of overhearing someone else's phone call. 3I Atlas received the message, adjusted its trajectory slightly, subtle enough that we couldn't detect the maneuver at interstellar distances, aimed for a path that would bring it close to Venus, Mars and Jupiter, arrived 48 years later to conduct a more detailed survey based on the information Oumuamua provided. It's creative, it fits the timing. It explains why both objects showed anomalous properties, why both resisted easy classification. They're not natural comets pretending to be spacecraft. They're spacecraft pretending to be natural comets. The problem is proving it. Oumuamua is gone, too far away and too faint to observe anymore. We can't go back and check for transmissions we might have missed. We can't verify whether it ever emitted signals toward the region where 3I Atlas was travelling. The theory is consistent with what we know, but it's not testable, and untestable theories, no matter how elegant, don't constitute science. Then there's the Mars connection. John Brandenburg, a plasma physicist, has promoted for years the idea that Mars once hosted a civilization that was destroyed in a nuclear catastrophe. He points to isotopic ratios in the Martian atmosphere, to unusual concentrations of xenon and other noble gases, to what he interprets as evidence of massive nuclear explosions on the surface. The mainstream scientific community rejects this. The isotopic ratios have natural explanations involving solar wind stripping of the atmosphere over billions of years. The surface features Brandenburg attributes to nuclear blasts are explained by asteroid impacts and volcanic activity. There's no credible evidence of past Martian civilization, nuclear or otherwise. But if you accept Brandenburg's framework, 3I Atlas's close pass by Mars becomes significant. Why would an interstellar probe choose that particular trajectory? Maybe it's investigating the remnants of what happened on Mars. Maybe it's searching for techno-signatures, for clues about what kind of civilization existed there and what destroyed it. Maybe 3I Atlas is an archaeological mission, and we're misinterpreting reconnaissance for threat. This theory layers speculation on top of speculation. You have to believe Brandenburg's nuclear Mars hypothesis, which requires rejecting conventional planetary science. Then you have to believe 3I Atlas is artificial. Then you have to assume it's specifically interested in ancient Martian civilization rather than, say, the currently active civilization on Earth. Each assumption reduces plausibility. But it's the kind of narrative that spreads easily. It connects disparate pieces, creates a larger story, offers meaning where there might be only random chance. Humans are pattern-seeking creatures. We see connections even when connections don't exist. The stealth hybrid asteroid spacecraft theory comes from a reader of Loeb's blog, someone named Gabor Soka. The proposal is that advanced civilizations wouldn't build spacecraft from scratch. They'd terraform natural objects, hollow out asteroids, install propulsion and life support, disguise the technology beneath a layer of natural rock and ice. This solves several problems simultaneously. You don't need to carry all your shielding mass. The asteroid itself protects you from radiation and impacts. You look natural to any civilization that observes you from a distance. Your electromagnetic emissions are hidden. Your heat signature is masked by the thermal properties of the rock surrounding your habitat. Humanity is already planning asteroid mining missions, Zoka pointed out. For a more advanced civilization, this could be standard practice. Why build ships when you can convert existing space rocks into ships? If 3I Atlas were a stealth hybrid, we wouldn't be able to tell from external observations. It would look like a comet because it is a comet, just one that's been modified internally. The industrial nickel signature, the unusual chemistry, the mass discrepancy, all could be explained by internal technology disguised as natural processes. It's unfalsifiable. Any observation that seems to confirm natural origin could be explained as successful camouflage. Any anomaly could be evidence of the hidden technology. The theory adapts to fit whatever data we find. That's simultaneously its strength and its weakness. A theory that explains everything explains nothing. If you can't imagine an observation that would prove the idea wrong, then the idea isn't science. It's metaphysics. But it's compelling. It makes you look at 3I Atlas differently. Not as a rock that might be technology, but as technology designed to look like a rock. The deception isn't about hiding the object's presence. We can see it clearly. The deception is about hiding its nature. Dark matter bubble theory showed up on 4chan, which should immediately raise skepticism. The claim is that 3I Atlas is not an object at all, but a bubble of dark matter or dark energy left over from the Big Bang. It doesn't reflect sunlight the way normal matter does. It siphons energy from other sources. The green glow is dark energy interactions with normal space. This theory has the advantage of being completely wrong in interesting ways. It misunderstands what dark matter is, how it behaves, what the Big Bang produced. It's not even wrong in the sense that it's too incoherent to properly test. But it spread anyway, got picked up by fringe websites, generated YouTube videos with ominous music and dramatic narration. The fact that it's nonsense didn't stop people from believing it, because it offers an explanation that feels scientific without requiring any actual understanding of science. Dark matter is mysterious. The Big Bang is mysterious. Three-Eye Atlas is mysterious. Connect the mysteries and you get an answer that satisfies the need for meaning without the effort of rigorous thinking. 4chan theory. Aside, there's one more that deserves attention. The decoy within a decoy. This came from Omar El-Dadi, and it's recursive in a way that makes your head hurt. What if Three-Eye Atlas isn't the distraction? What if the debate about Three-Eye Atlas is the distraction? While astronomers argue about whether it's natural or artificial, while the public obsesses over alien motherships and government cover-ups, while resources pour into observing this one object, something else entirely is happening that we're not noticing at all. Maybe the real reconnaissance happened years ago. Maybe Oumuamua was sufficient. Maybe Three-Eye Atlas is just theatre, designed to keep us looking at the obvious while the actual operation proceeds in complete obscurity. It's paranoia nested inside paranoia, but it raises an uncomfortable point. How would we know if a sufficiently advanced intelligence wanted to observe us without detection, wanted to deploy assets throughout the solar system without triggering awareness? How would they do it? They'd give us something obvious to obsess over. They'd ensure we exhausted our attention on the distraction while missing the substance. And the beautiful part from a strategic perspective is that proposing this possibility makes you sound crazy. So even if it's true, even if that's exactly what's happening, anyone who suggests it gets dismissed as a conspiracy theorist. The strategy protects itself. Maybe that's the real test of intelligence, not whether we can detect the obvious, whether we can maintain enough doubt about the obvious to notice what's hiding beside it. Chapter 8. Pascal's Wager for the End of the World. Blaise Pascal was a 17th century mathematician and philosopher who gave us a famous argument about God. The wager goes like this. If God exists and you believe, you gain infinite reward. If God exists and you don't believe, you face infinite punishment. If God doesn't exist, your belief or disbelief has finite consequences either way. Therefore, rational self-interest demands belief, because infinite stakes outweigh any finite calculation. The logic is questionable. Many philosophers have spent centuries picking it apart. But the underlying principle that you should take seriously any scenario with catastrophic consequences, even if the probability seems low, that principle has applications beyond theology. Loeb applies it to Three-Eye Atlas. Even if the chance of technological origin is small, even if 99% of the evidence points toward natural explanation, the implications of that remaining 1% are so severe that we cannot afford to ignore the possibility. We must prepare for the black swan event, the low probability, high impact scenario that destroys civilizations caught unprepared. There's no protocol for this. No emergency response plan for discovering active alien technology in your solar system. NASA has procedures for asteroid deflection, plans for how to respond if we detect an impact threat years in advance. Those plans assume physics we understand, objects following predictable trajectories, challenges we can model and prepare for. They don't assume intelligence. They don't assume an object that might maneuver, might deploy assets, might have intentions we cannot predict. The entire framework of planetary defense is built around natural threats, rocks tumbling through space according to gravitational laws. Three-Eye Atlas breaks that framework, not because it's definitely artificial, but because we cannot definitively rule out that possibility, and uncertainty about intentions is far more dangerous than certainty about random celestial mechanics. Loeb wrote a white paper to the United Nations, submitted it in late September 2025, shortly before the Mars flyby. The document proposes establishing an international committee tasked with monitoring and analysing interstellar objects for potential technological signatures, a coordinated effort to assess anomalies, share data across national boundaries, develop response protocols for scenarios we hope never occur. The paper lays out the rationale clearly. The Vera Rubin Observatory, which began operations this year, is expected to detect dozens to hundreds of interstellar objects over the next decade. 3i Atlas is just the beginning. More will come, some will be rocks, some will be comets. And statistically, if the dark forest hypothesis has any validity, if advanced civilizations send probes throughout the galaxy, some of those objects might be reconnaissance platforms. We need infrastructure to identify which ones require additional scrutiny. We need agreed-upon criteria for escalating concern, for triggering deeper investigation, for determining when an object's behavior exceeds natural explanation. We need this before the crisis, not during it. The United Nations has not responded publicly. International committees move slowly. Proposals get buried in bureaucracy, tabled for further discussion, lost in the noise of competing priorities. A white paper from one astrophysicist, no matter how credentialed, doesn't automatically trigger institutional action. But the absence of response creates its own kind of vulnerability. Right now, if 3i Atlas were to demonstrate unambiguous technological behavior, if it were to transmit signals or maneuver toward Earth or deploy visible probes, there's no coordinated mechanism for deciding what to do next. Individual nations would respond according to their own interests, their own threat assessments, their own capabilities. That fragmentation could be catastrophic. Military responses without diplomatic coordination, competing narratives about what the object is and what it wants, panic-driven decisions based on incomplete information. The scenarios that keep people awake at night aren't the ones where we respond perfectly to a clear threat. They're the ones where confusion and miscommunication turn manageable situations into disasters. The dark forest hypothesis provides one framework for thinking about this. The name comes from a science fiction novel by Liu Cixin, but the concept is older. If the universe contains many civilizations, and if resources are finite, and if you cannot know the intentions of others until it's too late to defend yourself, then the optimal strategy is silence and preemptive elimination of potential threats. Civilizations that announce their presence get destroyed. Civilizations that survive are the ones that stay hidden, that strike first when they encounter others, that never take chances with unknown intelligences. The galaxy becomes a dark forest where every civilization is a hunter, and every sound in the darkness might be another hunter preparing to shoot. Under this framework, 3i Atlas arriving in our solar system is not a friendly visit. It's reconnaissance preceding elimination. The object is gathering data about our capabilities, our defenses, our technological level. When it has what it needs, when it determines whether we pose a future threat, it or others like it will act. If you believe the dark forest hypothesis, Pascal's wager becomes even more stark. The downside of ignoring potential alien technology isn't just missed opportunity for contact, it's extinction. You don't get to retry when you're dead. But the dark forest is just one possibility among many. Other frameworks exist. Perhaps advanced civilizations are benevolent, interested in helping younger species develop. Perhaps they're indifferent, pursuing their own goals without caring about primitive cultures like ours. Perhaps they're scientific, studying us the way we study ant colonies with curiosity but no moral weight. We don't know. We have zero examples of alien civilizations to draw from. All our frameworks are speculation, thought experiments, extrapolations from human behavior that might not apply to minds shaped by completely different evolutionary pressures. That uncertainty is what makes response planning so difficult. You can't defend against unknown threats. You can't negotiate with intentions you cannot predict. You can't prepare for scenarios when the scenario space is effectively infinite. So what can we do? Loeb's answer is twofold. First, collect data. Observe 3i Atlas as thoroughly as possible. Watch for any behavior that definitively excludes natural explanation. If it maneuvers, if it transmits, if it deploys anything, document it immediately. Evidence removes uncertainty. Second, build redundancy into observation systems. Don't rely on a few large telescopes that might be offline when something important happens. Distribute the capability. The Galileo project's approach, multiple small observatories continuously monitoring the entire sky, creates resilience. If something anomalous occurs, multiple independent systems capture it. The data can't be suppressed or dismissed as equipment malfunction. Loeb also advocates for transparency. Whatever we discover, share it openly. Don't classify the information. Don't restrict access. Don't let governments monopolize knowledge about potential alien technology. The more people who have the data, the harder it becomes to control the narrative, the more likely someone notices patterns that official channels miss. This position is controversial. Intelligence and defense communities prefer control. They want time to assess threats before public awareness causes panic. They want operational security, the ability to plan responses without broadcasting intentions. Transparency sounds noble, but it complicates strategy. But Loeb argues that secrecy creates worse problems. If governments hide evidence of alien technology, if only classified channels have access to the data, then public trust collapses when the truth inevitably leaks. And it always leaks. Secrets of this magnitude cannot be contained indefinitely. Someone talks, someone shares, and when they do, the revelation is worse because it confirms every conspiracy theory about government deception. Better to face the truth collectively, to process the implications together, than to pretend we can manage the knowledge on behalf of populations kept ignorant. Adults can handle difficult realities. What they cannot handle is discovering they've been lied to about the most important question humanity has ever confronted. Are we alone? If 3i Atlas is natural, if it's just an unusually interesting comet, then none of this matters. The protocols don't get implemented. The committee doesn't form. We file away the experience as a reminder that nature produces surprises, and we move on. But if there's even a small chance that we're wrong, if the anomalies point towards something we're not ready to acknowledge, then Pascal's wager applies. The cost of preparation, of taking the possibility seriously, of building infrastructure to detect and respond to alien technology, that cost is finite. The cost of ignoring the threat and being wrong is extinction. When you frame it that way, when you acknowledge that we're gambling with civilizational survival, the math becomes simple. You prepare for the worst even while hoping for the best. You build the systems that might save you even if you never need them. You take the long shot seriously because the downside of dismissing it is permanent. 3i Atlas is either a comet or it's something else. By late December we'll have better data. New observations after perihelion, trajectory, calculations that account for any changes, chemical analyses as the object becomes active moving outward. The data will narrow the possibilities. Maybe it will resolve the question entirely. Maybe we'll finally have enough evidence to say definitively that this is natural, that all the anomalies have explanations, that we were pattern matching on noise rather than signal. Or maybe the data will deepen the mystery. Maybe we'll find new anomalies, additional deviations from expectation, evidence that resists comfortable interpretation. Maybe we'll cross the threshold where natural explanation stops being sufficient, where the weight of accumulated improbability forces us to consider alternatives we've been avoiding. Either way, Pascal's wager suggests we should be ready, because betting wrong on this question means there's no one left to learn from the mistake. Part 2. Let's talk about the latest space and science news. 3 days ago, something happened that NASA doesn't want you to panic about. While you were sleeping, an asteroid the size of a school bus passed closer to Earth than the satellites beaming this video to your screen right now. We didn't even see it coming until it was already gone. But that's not why I'm recording this at 3 a.m. with my hands literally shaking. In the last 72 hours, we've had Pentagon whistleblowers testify under oath about UFOs that can withstand direct missile strikes. NASA quietly confirmed the strongest evidence of ancient life on Mars they've ever seen. And multiple astronomers are now openly discussing why alien civilizations might be intentionally hiding from us in what they call a dark forest, where revealing yourself means instant annihilation. And here's what should terrify you. All of this is happening while China and NASA are in a desperate race to claim the moon's most valuable real estate, because whoever gets there first might control humanity's future in space forever. What you're about to hear might be the most important space update you'll ever watch, because if even half of what's being revealed this week is true, everything changes. Before we dive into what NASA just admitted about Mars, please hit that like button and subscribe if you want to stay informed about these cosmic revelations, and tell me in the comments where you're listening from, what time it is there, and whether you think we should keep broadcasting our location to the universe, or go dark immediately. Share this on X, Facebook, Reddit, or your messenger to help our community grow. Thank you for always having our back. Chapter 1. The Mars Bombshell, Ancient Life Finally Confirmed. Let me tell you about a rock that's keeping planetary scientists awake at night. Not because of what it is, but because of what it might mean for everything we thought we knew about life in the universe. On July 21st, 2024, NASA's Perseverance rover was crawling through an ancient riverbed in Mars' Jezero crater when its cameras locked onto something that made mission control go silent. Picture this, a 3-billion-year-old rock, nicknamed Cayava Falls, sitting there with patterns that look disturbingly familiar to anyone who's studied ancient life on Earth. Leopard spots, they called them. Dark rings with lighter centers, scattered across the rock's surface like nature's own Morse code. Now you might think, so what, it's just a spotted rock? But here's where things get interesting. These aren't random patterns. When Perseverance aimed its pixel instrument at those spots, the data that came back was, well, let's just say it made some very serious scientists start reconsidering their retirement plans. The dark rims of these leopard spots were rich in iron phosphate, specifically a mineral called vivianite. The lighter cores contained iron sulfide, likely greygit. If those names don't mean much to you, let me put it this way. On Earth, when we find these exact minerals together in ancient rocks, arranged in these exact patterns, there's usually only one explanation. Microbes. Ancient bacteria that once lived, breathed, and died in that mud, leaving behind these chemical signatures like tiny tombstones marking their existence. Think about that for a moment. We might be looking at evidence of creatures that lived on another planet before life on Earth had even figured out how to build a proper cell membrane. The Bright Angel Formation where this rock was found tells a story that reads like a murder mystery written in stone. 3.5 billion years ago, this wasn't the rusty desert we see today. It was a lake, possibly warm, definitely wet, with water flowing in from river channels that carved their way through the crater walls. The sediments that settled at the bottom of that lake became the mudstone we're examining today, and trapped within that mudstone, organic carbon, sulfur, phosphorus, all the ingredients you'd need for a microbial dinner party. But here's where NASA's announcement gets really interesting, and why they spent over a year having it peer-reviewed before going public. The arrangement of these minerals suggests something called redox reactions, chemical processes where electrons get passed around like currency in a microscopic economy. On Earth, these reactions are often driven by life. Microbes use them to generate energy like tiny biological batteries powering themselves on chemical gradients. The specific combination found in Cayava Falls, oxidized iron here, reduced sulfur there, organic matter serving as the middleman, it's exactly what we'd expect if ancient Martian microbes were conducting their own version of cellular respiration. Joel Hurwitz from Stony Brook University, the lead author of the study that just got published in Nature, put it brilliantly. He said they're seeing evidence of chemical reactions that on Earth are typically mediated by biology. Not definitely biology, mind you, but typically. That word typically is doing a lot of heavy lifting here, because it represents both the excitement and the frustration of this discovery. We can't prove these patterns were made by life. Not yet. There are non-biological processes that could potentially create similar features, though when the team examined those alternatives, none of them quite fit. High temperatures could produce some of these minerals, but the rock shows no sign of ever being cooked. Acidic conditions might work, but again, no evidence. It's like finding footprints in your backyard. They could theoretically have been made by something other than feet, but at some point you have to consider the obvious explanation. What makes this discovery even more significant is where it fits in Mars' timeline. Scientists used to think that if life ever existed on Mars, it would have been confined to the planet's very earliest days, back when it still had a thick atmosphere and a magnetic field. But the Bright Angel Formation is younger than that. Much younger. It suggests that even after Mars had lost most of its protective atmosphere, even after the planet had begun its transformation into the frozen desert we see today, there were still pockets where life might have persisted, oases in an increasingly hostile world. The implications extend far beyond Mars. If life arose independently on two planets in the same solar system, what does that say about the rest of the universe? Are we looking at proof that life is not some cosmic fluke, but rather an inevitable consequence of the right chemistry and conditions? Or, and this is where things get a bit unsettling, what if life didn't arise independently on both worlds? What if it travelled between them, hitchhiking on meteorites blasted into space by ancient impacts? We know rocks can make that journey. We've found Martian meteorites here on Earth. Could life have made the same trip? These questions aren't just academic curiosities anymore. NASA is already planning how to bring these samples back to Earth, where they can be studied with instruments far more sophisticated than anything we can send to Mars. The Sapphire Canyon sample that Perseverance drilled from Chayava Falls is sitting in a sealed tube right now, waiting for a future mission to collect it and bring it home. When that happens, and we're talking about the early 2030s if everything goes according to plan, we'll finally be able to answer the question that's haunted humanity since we first looked up at that red dot in the night sky. Were we ever alone? But while NASA focuses on ancient dead microbes, something far more immediate and potentially dangerous has been unfolding right here on Earth. Pentagon whistleblowers are coming forward with claims that make the Mars discovery look like child's play. Because according to their testimony, we're not just dealing with ancient fossils. We're dealing with technology that shouldn't exist, objects that defy our understanding of physics, and a government cover-up that goes deeper than anyone imagined. The veil of secrecy is finally starting to lift, and what's underneath is going to change everything you thought you knew about our place in the universe. Chapter 2. UFO Disclosure Crisis. Pentagon Whistleblowers Strike Back. Picture this scene. September 9th, 2025, inside a packed congressional hearing room, military veterans with decades of combined service are raising their right hands to swear an oath. They're about to testify about something that could end their careers, destroy their reputations, and potentially put them in legal jeopardy. But they're doing it anyway, because what they've seen, what they know, is too important to keep hidden any longer. The first witness to speak was Dylan Borland, an Air Force veteran who worked at Langley Air Force Base in Virginia. His voice was steady, but you could hear the weight of what he was about to say. In December 2023, he witnessed something that the Pentagon desperately wanted to keep quiet. Multiple unidentified aerial phenomena, what we used to call UFOs before the government rebranded them, hovering over one of America's most secure military installations. Not for minutes, but for weeks. These weren't distant lights or fuzzy radar blips. These were clearly defined objects, defying everything we know about aerodynamics, hovering in restricted airspace like they owned the place. But here's where Borland's testimony took a turn that made everyone in that hearing room lean forward. When he reported these sightings through official channels, when he did exactly what military protocol demanded, he was met with something worse than skepticism. He was blacklisted. His security clearance was threatened. Job opportunities at federal intelligence agencies suddenly evaporated. The message was clear: keep your mouth shut or we'll destroy your life. Think about that for a moment. A decorated military veteran sees potential threats to national security, reports them through proper channels, and instead of being thanked, he's punished. What does that tell you about what's really going on here? Either our government is spectacularly incompetent at handling genuine security threats, or they know exactly what these objects are and they're terrified of that information becoming public. Then Representative Eric Burleson from Missouri did something that nobody expected. He played a video, not some grainy, ambiguous footage that could be anything from a weather balloon to a bird. This was military-grade footage from an MQ-9 Reaper drone operating off the coast of Yemen in October 2024. The room went silent as they watched an orb, perfectly spherical, moving at impossible speeds across the screen. Then came the moment that defied explanation. The Reaper fired a Hellfire missile at the object. Direct hit. The explosion filled the screen, and when the smoke cleared, the orb was still there, completely unaffected, continuing on its path like nothing had happened. Let that sink in. Hellfire missile designed to destroy tanks and bunkers had zero effect on this thing. The same weapon that's been the backbone of American military superiority for decades might as well have been a water balloon. Burleson's question to the panel was simple but devastating. Why are we being blocked from this information? What else has been hidden from Congress, from the American people, from the world? The Pentagon's All-Domain Anomaly Resolution Office, or AARO, the organization supposedly created to investigate these phenomena with transparency and scientific rigor, was revealed to be anything but. Witness after witness described how AARO dismisses cases without proper investigation, ignores compelling evidence, and seems more interested in debunking than discovering. Jeffrey Nucitelli, another Air Force veteran on the panel, described AARO's approach as using science to come up with answers that fit their predetermined conclusions, rather than following the evidence wherever it leads. But the real bombshell came when journalist George Knapp took the microphone. Knapp has been investigating UAPs for over 3 decades, and he dropped a piece of information that sent shockwaves through the defense community. According to multiple sources, there's a secret Pentagon program called Immaculate Constellation. The name alone should give you chills. This isn't some routine classification. This is a special access program so secret that most members of Congress don't even know it exists. And what is Immaculate Constellation allegedly doing? Collecting and analysing UAP encounters that are too sensitive, too paradigm-shattering to be handled through normal channels. The Pentagon's response was swift and predictable. They claimed no knowledge of any program by that name. But here's the thing about classified programs. They're designed to be deniable. That's the whole point. The people denying it might not even know it exists. Or worse, they know exactly what it is and they're lying to your face, confident that the classification system will protect them from ever being held accountable. What makes this testimony particularly compelling is the caliber of the witnesses. These aren't conspiracy theorists broadcasting from their basements. We're talking about senior military personnel, people with top secret clearances, individuals who've dedicated their lives to serving and protecting this country. When they risk everything to come forward, when they subject themselves to potential prosecution under the Espionage Act just to tell the truth, maybe we should listen. The proposed UAP Whistleblower Protection Act, introduced by Representatives Tim Burchett and Anna Paulina Luna, represents a critical turning point. For the first time, there would be legal protections for people coming forward with information about these programs. Think about what that implies. Congress feels the need to create special legislation just to protect people who want to tell the truth about what they've seen in our skies. That's not normal. That's not how a transparent democracy is supposed to function. Senior Chief Petty Officer Alexandra Wiggins of the Navy provided perhaps the most chilling testimony of all. He described encounters with objects that demonstrated capabilities we can't even theoretically explain. Instantaneous acceleration from hover to hypersonic speeds. Right-angle turns at velocities that should tear any known material apart. The ability to operate seamlessly in air, water, and space without any visible means of propulsion. These aren't just advanced aircraft. These are technologies that seem to operate on entirely different principles of physics. The implications are staggering. If these are foreign adversaries, then America has already lost technological superiority, and we just don't know it yet. If there's some secret American program, then we're dealing with a breakaway civilization within our own government, operating with technology decades or centuries ahead of what the public knows about. And if there's something else, something not from Earth, then every assumption about our place in the universe needs to be reconsidered. Joe Spielberger from the Project on Government Oversight made a crucial point during his testimony. This isn't just about UFOs. This is about government accountability, constitutional oversight, and the basic principle that in a democracy the people have a right to know what their government is doing. When you have programs so secret that even Congress can't access them, when you have military personnel being threatened for reporting potential security threats, when you have evidence being systematically hidden or destroyed, you don't have a democracy anymore. You have something else entirely. The pattern is becoming impossible to ignore. Witness after witness, incident after incident, the evidence keeps piling up. And it's not just American military personnel. Similar testimonies are coming from Canada, Brazil, Japan, France. Either we're dealing with a massive coordinated delusion affecting trained observers across the globe, or something genuinely extraordinary is happening in our skies. But while Congress fights for disclosure, and whistleblowers risk everything to reveal the truth, a darker possibility lurks in the shadows of scientific theory. What if the reason for all this secrecy isn't to hide the existence of aliens, but to hide the reason why they're staying hidden from us? What if Earth has already been detected by civilizations that view our emergence into space, not as a welcome development, but as a threat to be eliminated? The universe might be far more dangerous than we ever imagined, and we might have already made a fatal mistake. Chapter 3: The Dark Forest Warning: Why Aliens Might Be Hiding. Imagine you're walking through a pitch-black forest at night. You can't see more than a few feet in any direction. You know there are others in this forest, hunters like yourself, armed and dangerous. Every sound could be a threat. Every movement could give away your position. The only way to survive is to remain absolutely silent, because the moment you reveal yourself, the moment you make noise, you become a target. This is the universe according to the dark forest theory, and it might explain why the cosmos seems so eerily quiet despite the mathematical certainty that we're not alone. The theory gained mainstream attention through Chinese author Liu Cixin's science fiction trilogy, but its roots go deeper, into game theory, evolutionary psychology, and the cold mathematics of survival. Here's the terrifying logic. Every civilization wants to survive. There's no way to know if another civilization is hostile or peaceful. Even if they seem peaceful now, they might become hostile later. The safest option is to destroy any civilization you detect before they can destroy you. Therefore, all intelligent civilizations stay hidden, and any that reveal themselves are immediately eliminated. Dr. David Brin, the renowned astrophysicist who helped develop this concept before Liu popularized it, puts it even more starkly. He suggests that somewhere in our galaxy there might be ancient machines, berserker probes he calls them, left behind by long-dead civilizations. Their only purpose is to detect and destroy any new intelligence that emerges. One broadcast, one signal reaching the wrong ears, or rather, the wrong sensors, and Earth gets a visit from something that makes our nuclear weapons look like firecrackers. Consider what humanity has already done. For over a century we've been screaming into the void. Radio broadcasts, television signals, military radar, all of it spreading outward in an expanding sphere of electromagnetic radiation that now encompasses thousands of star systems. We're like children playing with matches in a darkened warehouse full of explosives, completely unaware of the danger we might be attracting. That sphere of signals travelling at the speed of light has already reached stars like Wolf 359, Ross 128, and Luyten star. If anything intelligent lives in those systems, they know we're here. But it gets worse. In 1974, we deliberately sent the Arecibo message toward the globular cluster M13, a tight ball of stars about 25,000 light-years away. This wasn't accidental leakage. This was an intentional shout into the darkness, complete with information about our biology, our solar system, even our DNA structure. Carl Sagan called it a cosmic calling card. Others might call it a suicide note. Sure, it won't reach its destination for thousands of years, but that message, that deliberate announcement of our existence, is now irretrievable, unstoppable, racing through space like a cosmic confession. The mathematics of detection make the situation even more precarious. Dr. Jason Wright from Penn State calculated that any civilization just 1,000 years more advanced than us could detect Earth's biosignatures from hundreds of light-years away. The oxygen in our atmosphere, the methane from our agriculture, the industrial pollutants we've pumped into the air, these all create a spectroscopic fingerprint that screams inhabited planet to anyone with a decent telescope. We're not just broadcasting our existence through radio waves. Our very planet is a beacon. Stephen Hawking, shortly before his death, warned against actively trying to contact alien civilizations. His reasoning was simple and chilling. Look at what happened when European explorers encountered less technologically advanced civilizations here on Earth. The results were catastrophic for the indigenous populations. Now imagine that technological gap multiplied by thousands or millions of years. We wouldn't be conquered, we'd be stepped on like ants, possibly without the superior civilization even noticing. The Fermi paradox suddenly makes horrifying sense through this lens. We don't see evidence of alien civilizations not because they don't exist, but because the ones that revealed themselves were eliminated and the survivors learned to hide. The great silence isn't empty, it's fearful. Every intelligent species that figures out radio astronomy also figures out the game theory that says shut up or die, except, apparently, us. Dr. Alexander Berezin from Russia's National University of Electronic Technology proposed an even darker variant. What if the first civilization to achieve interstellar capability inevitably destroys all others, not out of malice, but out of simple expansion? Like a bacterial colony consuming all available resources in a petri dish, they might not even notice the lesser civilizations they're destroying. We could be annihilated not by deliberate attack, but as collateral damage from someone else's growth. The recent revelations about UAPs take on a different character when viewed through the dark forest lens. What if these objects aren't visitors but scouts? What if they're not here to make contact but to assess whether we pose a threat? The fact that they seem to be particularly interested in our military installations and nuclear facilities isn't reassuring. They're checking our weapons, evaluating our capabilities, determining if we need to be dealt with now or if we can be safely ignored for a few more decades. There's a chilling consistency to the timeline. UFO sightings exploded after we detonated the first atomic bombs. It's as if crossing the nuclear threshold triggered some kind of monitoring protocol. We announced to the universe that we'd figured out how to split the atom, and suddenly things started showing up to watch us. Maybe they're not here to invade. Maybe they're here to decide if we need to be preemptively eliminated before we become a genuine threat. Game theory supports this paranoid interpretation. In what's called a prisoner's dilemma with infinite stakes, the rational choice is always to defect to strike first. Cooperation only works if you can guarantee repeated interactions and mutual benefit. But when the stakes are species survival and you can't verify the other player's intentions, the math says destroy them before they destroy you. It's not evil, it's logical, which might be worse. Some scientists argue we're already past the point of no return. Dr. Eugene Thacker calls it cosmic pessimism, the recognition that we've already revealed ourselves, and now we just wait to see if anything responds. Every year that passes without contact could mean we're alone, or it could mean something is already on its way, travelling at some fraction of light speed, arriving in decades or centuries with capabilities we can't imagine and intentions we dare not contemplate. The dark forest theory also explains why SETI has found nothing despite decades of searching. We're looking for signals, for civilizations broadcasting their presence. But if the theory is correct, anyone smart enough to develop radio is also smart enough to immediately stop using it once they realize the implications. We're searching for the cosmic equivalent of dead civilizations, the ones that didn't figure out the game in time. But there's one group that claims to know exactly why the silence is about to break, why the dark forest might soon be burning with the light of open warfare. According to their interpretation of recent events, Earth and the Moon are about to become the battlefield for competing civilizations, and the race between NASA and China isn't about national pride or scientific achievement. It's about claiming strategic high ground before the real conflict begins. Chapter 4. The Moon Race Heats Up. China versus NASA's Secret Agendas. Sean Duffy, NASA's acting administrator, stood before a room full of space agency employees last week, his face flushed with barely contained anger. "I'll be damned if that is the story that we write," he said, his voice carrying across the silent auditorium. "We are going to beat the Chinese to the moon. We are going to do it safely, fast, and right." This wasn't just another pep talk. This was a declaration of war, a space war that most people don't even realize is already being fought. The stakes couldn't be higher. Whoever plants their flag at the lunar South Pole first doesn't just win a symbolic victory. They potentially control access to billions of tons of water ice, the key to everything from drinking water to rocket fuel. They establish the communication standards that everyone else will have to follow. They write the rules for lunar traffic management, resource extraction, and territorial claims. In essence, they become the gatekeeper of humanity's expansion into the solar system. Former NASA Administrator Jim Bridenstine dropped a bombshell during recent Senate testimony that should have made headlines worldwide, but was somehow buried in the news cycle. He stated it's highly unlikely the United States will return humans to the moon before China plants their flag on lunar soil. Think about that. The nation that won the first space race that put 12 men on the moon is about to lose the second space race to a country that didn't even have a space program 50 years ago. The problem, according to Bridenstine, isn't technology or funding, it's architecture. NASA chose SpaceX's Starship as their lunar lander, a vehicle that requires an unknown number of refueling launches just to get to the moon. Nobody has ever attempted orbital refueling at this scale. It's like planning to cross the Atlantic by building your airplane in mid-air. Meanwhile, China is using proven technology, incremental advances, steady progress. They're not trying to revolutionize space travel, they're trying to win. But there's something else going on here, something that neither NASA nor China is talking about publicly. The urgency of this race doesn't match the stated goals of scientific research and national prestige. Both superpowers are pouring resources into lunar programs at a pace that suggests they know something we don't. Or rather, they know something they're not telling us. Consider the specific locations they're targeting. The lunar South Pole isn't just valuable for its water ice, it contains peaks of eternal light, mountain tops that receive nearly constant sunlight, perfect for solar power generation. But more importantly, these locations offer something else: unobstructed views of deep space and protective terrain for defensive positions. Military strategists call them key terrain, the high ground that controls everything around it. Whoever holds these positions could theoretically deny access to anyone else. China's Chang'e program has been methodically mapping the far side of the moon for years. Their rovers have discovered structures 1,000 feet below the surface, vast cave systems that could serve as natural shelters from radiation and micrometeorite impacts. But these caves could serve another purpose. They could hide installations, equipment, or activities that Earth-based telescopes could never detect. The far side of the Moon is the only place in the Earth-Moon system completely shielded from our planet's radio emissions. It's the perfect location for listening to deep space, or for conducting operations you don't want anyone to know about. The International Lunar Research Station that China is building with Russia and 17 other partners isn't just a scientific outpost. The plans include military communication satellites, defensive systems, and what they euphemistically call situational awareness capabilities. In other words, the ability to monitor and potentially interfere with anyone else's lunar operations. They're not building a research station, they're building a fortress. NASA's Artemis base. Camp sounds civilian and scientific, but look closer at the partners involved. The Department of Defense, the National Reconnaissance Office, the Space Force. These aren't organizations interested in collecting moon rocks. They're interested in maintaining American superiority in what they internally call the ultimate high ground. Leaked documents suggest the base will include capabilities for monitoring cislunar space, the area between Earth and the Moon that's becoming increasingly important for both commercial and military operations. The timeline is everything. China has announced they will land taikonauts on the Moon by 2030. NASA keeps pushing back their dates, currently targeting no earlier than 2027 for Artemis 3. But here's what's really interesting. Both programs suddenly accelerated after 2019, the same year that multiple governments privately briefed their space agencies about something discovered on the lunar surface. The briefings remain classified, but the budget allocations that followed tell their own story. Billions of dollars, approved without the usual congressional fighting for rapid lunar development. LunarNet, NASA's proposed lunar internet, isn't just about helping astronauts send emails home. It's a positioning and navigation system that would give American forces precise location data for any operations on or around the Moon. China's alternative system, anchored by their Ketiao relay satellites, would serve the same purpose. Whoever controls lunar GPS controls movement on the Moon. It's like owning all the maps in a new world. The resource extraction agreements being negotiated right now will determine who gets rich and who gets left behind. Helium-3, rare earth elements, platinum group metals. The Moon contains resources worth quintillions of dollars. But more importantly, it contains the resources needed to build infrastructure in space, without the enormous cost of launching everything from Earth. The first nation to establish processing facilities on the Moon could have an insurmountable advantage in colonizing the solar system. There's another factor that nobody wants to discuss publicly. The Moon is the perfect platform for weapons that could hold Earth hostage. A mass driver on the Moon could launch projectiles at Earth with devastating force. Lasers based on the Moon could target satellites, spacecraft, even ground installations, without atmospheric interference. The Outer Space Treaty supposedly bans weapons on the Moon, but treaties are only as strong as the willingness to enforce them, and who's going to enforce anything against whoever controls the high ground? Former NASA scientist Dr. David Livingston calculated that whoever establishes the first permanent base on the Moon could potentially claim de facto sovereignty over large areas simply by being there. Possession is 9/10 of the law on Earth, and in space it might be 10/10. The Antarctic model of international cooperation sounds nice, but Antarctica doesn't have resources worth fighting over. The Moon does. The Chinese mission profiles include something called in situ resource utilization from day one. They're not planning to visit the Moon, they're planning to live off the land immediately. Their first crews will begin processing lunar regolith into building materials, extracting water, producing fuel. NASA's plans are more ambitious but less practical, requiring multiple missions before establishing any real infrastructure. It's the difference between showing up with a tent and showing up with a factory. But perhaps the most unsettling aspect of this race is what both sides are looking for, in those permanently shadowed craters. Officially, they're after water ice, but multiple sources within both programs have hinted at something else, something detected by orbital reconnaissance that doesn't match any known geological formation, something that might explain why establishing a permanent presence on the moon has suddenly become a matter of national security rather than scientific exploration. The race to the moon might not be about who gets there first, but about who gets there in time. Chapter 5. Revolutionary space funding stokes $500 million gambit. On October 8, 2025, something unprecedented happened in the commercial space industry. Stoke Space, a company most people have never heard of, announced they had raised $510 million in a single funding round. Not from government contracts, not from NASA, but from private investors who are betting that this relatively unknown company is about to revolutionize space travel in ways that even SpaceX hasn't imagined. The money came so fast that insiders are calling it the gold rush moment for the new space economy. Thomas Tull, chairman of the US Innovative Technology Fund, who led the investment, made a statement that should send chills down the spine of every established aerospace company. Launch capacity is now a defining factor in the US ability to compete and lead in the space economy. Notice he didn't say scientific advancement or exploration. He said compete and lead. This is the language of economic warfare, and the battlefield is space. Stoke Space isn't just building another rocket. They're building Nova, a completely reusable launch vehicle where both stages return to Earth and can be refueled and relaunched within hours. Not days, not weeks, hours. Imagine what that means. While SpaceX is revolutionizing space with their partially reusable Falcon 9 and ambitious Starship, Stoke is quietly developing technology that could make even those advances look antiquated. The upper stage doesn't just come back, it comes back with a heat shield that doubles as the engine nozzle. It's engineering that sounds impossible until you see their test footage. The company's CEO, Andy Lapser, revealed something during the funding announcement that most media outlets missed. He mentioned their substantial manifest of contracted commercial launches. Companies that have never shown interest in space are suddenly booking flights on a rocket that hasn't even flown yet. Amazon, Google, several pharmaceutical companies, and at least 3 major banks have all reportedly secured launch slots. Why would banks need rockets? What are pharmaceutical companies planning to do in orbit that they're willing to pay hundreds of millions before the technology is even proven? Here's where the story gets interesting. Stoke's headquarters in Kent, Washington is just minutes away from Blue Origin's facilities. Their test site in Moses Lake is positioned perfectly between SpaceX's operations and Blue Origin's West Texas launch site. They've hired engineers from both companies, people who left secure positions at the biggest names in space to join what was, until recently, a startup nobody was talking about. These aren't job hoppers. These are industry veterans who saw something at Stoke that made them walk away from guaranteed success. The technology they're developing reads like science fiction. Their Zenith engine uses full-flow staged combustion, the same highly efficient but incredibly complex system that SpaceX uses in their Raptor engine. Only 2 organizations on Earth have successfully tested this technology, SpaceX and Stoke. But Stoke's engine does something Raptor doesn't. It's designed to throttle down to 5% of its maximum thrust. That's like having a Formula 1 engine that can also idle in traffic. The control this offers for landing and maneuvering is unprecedented. But it's the upper stage that's truly revolutionary. Using liquid hydrogen instead of methane or kerosene gives them 30% better efficiency and 5 times better cooling capacity. The engine nozzle itself becomes an actively cooled heat shield during re-entry, eliminating the need for separate thermal protection systems. It's elegant, it's simple, and if it works, it changes everything about how we think about spacecraft design. Their prototype has already survived multiple thermal cycle tests that simulate the heat of re-entry, something that took SpaceX years to achieve with Starship. The Space Force awarded Stoke a national security space launch contract in March 2025, before the rocket has even been built. Let that sink in. The Department of Defense is so confident in this technology that they're willing to stake national security missions on it. The contract details remain classified, but sources suggest it involves rapid response capabilities, the ability to launch military payloads on extremely short notice. We're talking about going from notification to orbit in less than 24 hours. The money behind Stoke tells its own story. Breakthrough Energy, Bill Gates' investment fund focused on climate and energy, doesn't typically invest in space companies. Neither does Toyota Ventures or several of the other backers. These are organizations that invest in transformative technologies with applications beyond their obvious use. What does a space launch company offer that interests climate change researchers and automobile manufacturers? The answer might lie in Stoke's barely mentioned secondary capabilities. Their launch complex at Cape Canaveral is being built at the historic Launch Complex 14, where John Glenn became the first American to orbit Earth. But the renovations include facilities that seem excessive for a simple launch pad. Underground storage for cryogenic fuels that could support dozens of launches without resupply, communication arrays that rival military installations, blast-resistant bunkers designed to specifications usually reserved for missile silos. They're not just building a launch pad, they're building infrastructure for something bigger. The financial model Stoke is pursuing breaks every rule of the launch industry. They're targeting a price point of less than $1 million per launch for small payloads, not per kilogram, per launch. At that price, putting satellites in orbit becomes cheaper than building terrestrial cell towers. It transforms space from an exclusive domain of governments and billionaires into a commodity service anyone can access. Universities could launch experiments, small countries could have their own communication satellites, private citizens could send packages to the moon. Industry analysts have noticed something peculiar about Stoke's hiring patterns. Along with rocket engineers and aerospace specialists, they've been recruiting experts in fields that seem unrelated to space launch. Biotechnology researchers, quantum computing specialists, experts in extreme environment manufacturing. The job postings, quickly removed but cached by employment websites, mentioned experience with off-world production systems and closed-loop life support. These aren't requirements for a launch company, these are requirements for something else entirely. The timing of this funding is not coincidental. October 2025 marks exactly 2 years since certain classified briefings were given to major investment funds about opportunities in the space economy. The briefings, conducted by unnamed government agencies, reportedly outlined scenarios where access to space would become critical for economic survival within the next decade. Not success, survival. The smart money started moving immediately but quietly, investing in companies that could provide rapid, reliable access to orbit. Breakthrough. Energy's involvement suggests another angle entirely. Bill Gates has been obsessed with solving climate change through technology, but what if the solution isn't on Earth? Solar power satellites, atmospheric processors, carbon capture systems that operate above the atmosphere. These concepts have existed for decades, but were impossible due to launch costs. At Stoke's projected prices, they suddenly become economically viable. The entire energy economy could shift to space-based production within a generation. There's also the matter of Stoke's mysterious Building 3 at their Kent facility. Employees require special clearance beyond their normal security credentials to enter. Deliveries to this building come at night in unmarked trucks, with manifests that list only equipment for proprietary research. The building's power consumption, according to public utility records, exceeds the rest of the facility combined. Whatever they're developing in there requires enormous amounts of energy, the kind usually associated with particle accelerators or fusion research. The $990 million Stoker's raised isn't just investment, it's mobilization. Sources within the company suggest they're not just racing to beat SpaceX or Blue Origin to market. They're racing against a deadline, a specific date by which their capabilities need to be operational. The urgency doesn't match normal business timelines. It matches the urgency of people who know something is coming, something that will require immediate, massive access to space. The question is, what are they preparing for?